Welcome to Your Math Explained, where we make math simple and clear. My name is Angela. Up to now, you've probably relied on your calculator to get values of sine, cosine, and tangent. But what if I told you that you can know the exact values of certain key angles without a calculator? That's where special triangles and axis angles come in. Today, we'll build the 30-60-90 triangle and the 45-45-90 triangle. And then we're going to use these to unlock the exact values of trig ratios. We will also draw these in radian measures. Finally, we'll expand this to the main axis angles on the unit circle. So let's start with the 45-45-90 triangle. And we're going to start building it by drawing a square. So we're going to have a square where all four lengths are equal to 1. So that means this is 1, 1, 1, and 1. Next, we're going to draw a diagonal through this square. So notice how this triangle here, which I will highlight, will have a right angle at the bottom. And then these two are going to be 45 degrees because we've cut the 90 degrees in half. And then we can go ahead and use our Pythagorean theorem to go find this diagonal, which I've labeled as c. So we would get 1 squared plus 1 squared is equal to c squared. Solving for c gives us c is equal to the square root of 2. So now let's go ahead and actually just draw the triangle. And this time, I'm going to draw it twice. The first one is going to be in terms of degrees. So that means this will be 45 degrees, 45 degrees, and 90 degrees. And then the second one, I will be drawing it in terms of radians. So the triangle is the exact same shape, but we're going to label the angles in radians. So that means this one is going to be pi over 4, and the top one is also pi over 4. And we're going to label both of these triangles. So we would have 1, 1, root 2. And this one would have the same, 1, 1, root 2. And now we're ready to write down our trig ratios. So in degrees, we would have sine of 45 degrees is equal to 1 over root 2. And we have cosine of 45 degrees is also 1 over root 2. And then lastly, we have our tangent of 45 degrees, which is equal to 1 over 1, so that'll just be equal to 1. And in radians, that's going to be sine of pi over 4 is equal to 1 over root 2. And cosine of pi over 4 is also 1 over root 2. And then our tangent of pi over 4 is going to equal to 1. So one thing that you might notice is that certain books have a different number, which is root 2 over 2. And this is because we can rationalize 1 over root 2 by multiplying the top and bottom by root 2. And if we do that, we're going to get this is equal to root 2 over 2. So they're actually the same, and both forms can show up. Next, we're going to take a look at the 30-60-90 triangle. And we're going to construct that by drawing an equilateral triangle. So an equilateral triangle is just a triangle where all three angles are 60 degrees. And we're going to make it so that this triangle has a side length of 2. So next, we're going to go from the top vertex. We're going to drop a height all the way down to our base. So this is going to be 90 degrees here. This angle here is still 60 degrees. But then our top angle is now 30 degrees because we've cut that angle in half. But that also means this segment of the triangle is going to be half of the base of this equilateral triangle, which is now going to be 1. And again, we can go ahead and use Pythagorean theorem to find our height c. So we have 1 squared plus c squared is equal to 2 squared. And then solving for c would give us this is equal to the square root of 4 minus 1, so which is square root 3. So just like what we did earlier, we're going to go ahead and draw the triangle out by itself. And we're going to do it in both degrees and radians. So this would be 60 degrees, 30 degrees, and this here is our right angle. And then this would have a side of 1, 2, root 3. I'm going to repeat the same thing in terms of radians. So this is going to be like this. This angle here will be pi over 3. The top angle is pi over 6, and this is our right angle. And then same thing, we have 1, 2, root 3 as our sides. So now each triangle is going to have 6 trig ratios because we have 2 different angles to deal with, a 30 degrees and a 60 degrees. So let's start with the 30 degrees first. So that one's going to be sine of 30 degrees is opposite over hypotenuse, which is 1 over 2. And then cosine of 30 degrees is going to be adjacent over hypotenuse. So that'll be root 3 over 2. And then tangent of 30 degrees is going to be equal to opposite over adjacent, which is 1 over root 3. The radian equivalent would be sine of pi over 6 is equal to 1/2. Cosine of pi over 6 is equal to root 3 over 2. And tangent of pi over 6 is 1 over root 3. And now let's go do the same thing with the other angle. So that'll be sine of 60 degrees is equal to opposite over hypotenuse, which is now root 3 over 2. Our cosine of 60 degrees is now 1 over 2. And our tangent of 60 degrees is now root 3 over 1, which is just root 3. Repeat the same thing for radians. We get sine of pi over 3 is root 3 over 2. Cosine of pi over 3 is 1/2. And tangent of pi over 3 is equal to square root 3. And there you have it. These are our 2 special triangles and all the trig ratios corresponding to them. Next, we're going to tackle our axes angles. So axes angles are 0, 90, 180, 270, and 360 degrees because they lie on the axes. The issue with these angles is that we can't create triangles as they don't lie in the quadrants as we did in our previous video with standard positions. These values are just better to be memorized, but we'll show you how we can generate some of these values by the following process. So we're going to start by drawing our x and y axes. And what I'm going to do is I'm going to draw a terminal arm, but I'm going to make it very close to the positive x-axis. So now, imagine that this point lies on the unit circle. So that means the hypotenuse is our radius, which is equal to 1. Now this triangle is going to have a base of x and a height of y. And this is our angle theta. So now sine theta is equal to opposite over hypotenuse. So that's going to be y over 1, which is just y. And our cosine theta is going to be adjacent over hypotenuse. So that'll be x over 1, which is just x. And then our tangent theta is going to be opposite over adjacent, which will be y over x. Next, what I want you to do is imagine we're going to start pushing this radius down so that it gets closer and closer to the x-axis until it basically lies on the x-axis. So what happens then? Well, if it's lying on the x-axis, then that means our theta is really just now 0. And our x is going to be equal to the radius because they overlap. So that's going to be 1. And our y is now 0 because our triangle has a height of 0. So therefore, the trig ratios here are going to be sine theta, or sine of 0, is going to be 0 because that's our y value. Cos theta is equal to 1 because that's our x value. And tangent of 0 is the y value over the x value, which is 0 over 1, so that's going to be 0. And now we do the same thing for 90 degrees. So our triangle would be really close to the y-axis. So now, this is our angle theta. And what we're doing this time is we're pushing it until it goes closer and closer to the y-axis. And what happens then? Well, our theta is now going to be 90 degrees. Our x value is now 0. And then our y value is now the radius, which is 1. So therefore, sine theta is equal to y, which is 1. Cos theta is equal to x, which is 0. And tangent theta is going to be y over x, which is 1 divided by 0, which is undefined because we cannot divide by 0. Next, we're going to go and do the 180. So that'll be this triangle here. So again, we're going to push this down until it lines up with the negative x-axis. So in this case, our theta is equal to 180 degrees. Our x value is -1. And our y value is 0. So this means our trig ratio is going to be sine of 180 will be 0. Cos of 180 is -1. And tangent of 180 is going to be 0. And the next one is going to be 270 degrees. So that'll be this triangle down here. And this time we're squishing it so that it gets closer and closer to the y-axis until it overlaps. So we would have our theta is equal to 270 degrees. Our x value is now 0. And our y value is now -1. So that means our trig ratios are going to be -1, 0, and again, tangent of 270 is going to be undefined because we're dividing by 0. Now the last one is 360 degrees, but that is just the very first triangle that we drew because 360 is just one full rotation, so we're already back at 0, which means the values are going to be the same as that of 0. So that'll be 0, 1, 0. So now if we exceed this full rotation, then the circle is just going to repeat itself. So the values will continue to repeat as well. And now let's go ahead and do a recap of everything that we covered in this video. We built our special triangles, the 45, 45, 90, and the 30, 60, 90. We used them to find the exact values of sine, cosine, and tangent of those angles. We then extended to the axis angles on the unit circle. These special values are the foundation for solving trig equations, graphing trig functions, and many contest-style problems. And now it is your turn to give this a try. Can you find the values of these 3 problems here without the use of a calculator? Make sure to leave your answer in the comments below and let us know if you'd like to see more content that involves special angles in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.